Your homework, just hang on to it. If we have time at the end, maybe we'll go over it. The last class we ran out of time, so it's more important that we finish this lesson. And I just might take the homework tomorrow, the worksheet. All right, so here we go. Lesson 10.7, section 10.7. And what we have is we have two chords that intersect inside a circle. That looks very familiar to what we did yesterday, doesn't it? Remember that one? Okay, if you have two chords that intersect, oh, actually, day before, whatever it was. Okay, yesterday you just did a worksheet, but the day before, the last lesson we did this. But we talked about the angles and we talked about the arcs, didn't we? This time, I'm not going to talk about the angles and the arcs. I'm actually going to talk about the lengths of the segments themselves. It's a chord, so it goes from here on the circle to over here on the circle. Same thing with the other chord, and they intersect each other. They intersect inside the circle. Make sense? Okay, we're going to talk about the lengths of those. Let's go with a different color here. So let's just call this length right here A. So if I said this is A and I just stuck it there, people say, well, is it the whole thing or is it just, where is it? Well, if there's nothing else telling you, if it, you don't have like this. If you had something like that, then that would mean the whole thing, wouldn't it? Well, we don't have that. We just have an A sitting right there. So automatically that's going to mean from this point to this point right here. So on the circle to there. Everybody understand that? So that's line segment A. What about this little line segment right here? Well, we'll call that B. We'll do the same thing with this one, and we'll do the same thing with this one. Call that C and D. Now, what's cool about this, we're not going to really go through like why or anything that this is true. We'll just learn it. So if I'm going to get a little bit wordy here, but try to figure out what I'm saying. If I took the product, what does that mean?
The answer.
The answer to what?
It's multiplication.
Multiplication. Product is multiplication. If I took the product of the two segments of this chord, did you hear what I just said? The product of the two segments of the chord. So what is that? What is the product of the two segments of that chord? A times B. Good. Right? Product means we multiply the segments. What segment? Well, A and B. Right? They're the two segments of the chord. If I take the product of them, multiply them together, I just get AB. Now that's going to equal the same thing on the other chord. The product of the two segments of the other chord. It doesn't mean the two chords are equal to each other. Everybody understand that? It doesn't mean that this whole chord is equal to this whole chord. I mean, it could, but it doesn't mean it has to. It just means if they intersect each other, it's broken up into two segments. Each chord is broken up into two segments. The product of those two segments are equal to each other. So A times B is going to equal, what do you think? C times D. Exactly right. It's not too hard. Now, you might not understand like who came up with it, where it came from, but on this one, that's okay. We'll just remember it. Pretty simple little equation, isn't it? So if I just take this chord and this chord, I multiply them together. Now I don't add them, because if I added them together, what would be true about these two chords? They would have to be the same. They have to be equal to each other. But so it's not the addition, it's the multiplication. It's this times this equals this times this. Make sense? All right, let's put a number in here. Oh, where'd my book go? Let's pause. All right, now I got my book here. Let's put some numbers in here. I'm just going by the ones in the book. So you know what I should do? Let's pause again. I'm going to get rid of the A, B, C. All right, let's put some numbers here. This is, we'll call this X. We'll call this 10. We'll call this one 5. And this one we'll call 12. This is not too hard. It's pretty simple. Okay, the next one, it's a little bit more challenging than this one, but this one's pretty easy. I just started off with a real simple one right now. What's that? Just hang on. Oh, that's a quiz. Oh, okay. Gotcha. All right, so what are we going to do? AB equals CD. So we take the two segments of this chord, multiply them together, and it equals the two segments of this chord. You should be able to just do that in your head if you want to, but we'll write it down. So let's do this one first, the one with the X. So it's 10 times what? X equals what? 5 times 12. Yeah, it is 60, but I'm just going to show you the steps just so everybody sees everything that I'm doing. So 10x is 60, x is 6. Just 6, pretty simple. All right, very easy. Everybody got that? Not too hard at all. Let's do one more. We'll do different values here instead of just these easy ones. The algebra is just a little bit tougher, but the geometry is about just the same. All right. Okay, now let's do a different one. Let's call this one. Now, again, it's not really drawn to scale or anything. So we'll just stick them in here. Let's call this one X. Call this one down here X plus 10. Let's go to the other one, and we'll call this one X plus 1, and we'll call this one X plus 8. There we go. And fact, watch, this is kind of cool. See, I grabbed everything, right? Now I could do that, or I could hit Control G. See what it did? And now watch, I can grab anywhere in here. Watch, I can even click off of it and then just touch it anywhere here, and it grouped it all together, so I can move it all as one group. It's kind of slick, isn't it? Yeah. You guys seem so impressed. Okay. Let's set up the geometry. Here we go. Let's set up some geometry. So we're going to take this segment times this one equals this one times this one. Doesn't matter how you do it. Let's just do this x and this x plus 10. So we multiply those together. So it's x times x plus 10. Make sure you put the x plus 10 in parentheses, all right? Because it's a sum. When you multiply a sum, you need to put it in parentheses. Let's do the same thing here. Let's take this one and this one, multiply those together. Do you see something that we're going to have to do here? FOIL, right. We're going to have to do the FOIL method, okay? Let's do this one. Just regular distributive property. That's going to be x squared plus 10x. Let's FOIL this one. X times x is x squared plus 1x plus 8x is 9x plus 8 times 1 is 8. You remember that from Algebra 1, don't you? We haven't done it a whole lot in here. We've done it a few times, though, haven't we? Yeah. Okay, not too much, but a little bit. We want to solve for x. Look what happens. This is nice. You don't even have to worry about the x squareds now. What happens to them?
They cancel.
Yeah, everybody says cancel out. Yeah, that's right, Isaiah. I would do that. I would just say subtract them from both sides. Yeah, technically, I guess you could say cancel, but we say cancel sometimes way too much. So I like to say what's really going on. Why did we get rid of them? We got rid of them because we subtracted from both sides. Make sense? Now what we can do is subtract a 9x. You could have just done that in your head, but I'll just show you. So x equals what? That went 8. And there it is. So if they just say solve for x, there it is. Now, of course, they could ask you, right, they might label this and say solve for line segment AC. All right, if you wanted to do that, that would be easy. Just put 8 in here, put a what? 8 right here, so this would be 18, and this would be 8, so what's this whole segment right here? 26, right, that'd be 26. You follow me? So they could ask for all that, but once you solve for x, you've been doing that all year, haven't you? You take a geometry principle, and then they put in values for it, they put in some x's, and you find some x's. Remember the beginning of the year I told you that we would be doing that all year long? I'm like, geometry doesn't really get harder and harder. I don't think it does. I think it's just the same kind of things that we did from the beginning. It just changes shapes, right? You do kind of the same thing for triangles, for parallelograms, for circles, for, did I say triangles? Okay, for all those different things. All right, and so we kind of repeat that same thing over and over again. It's just different shapes have different equations and all that, but it kind of boils down to the same math. I mean, how many times have we done this? A bunch of times, haven't we? This kind of stuff, and you put it into x and you solve for x. So that's the kind of nice thing about geometry. All right, that's one theorem. We're going to do 3 of them. So that's the first one. So again, what is it? 2 chords that intersect where? Talk to me, come on.
Right there.
Yeah, right there, yeah. Inside the circle, right? They intersect inside the circle. All right, let's do another one. All right, now we did 2 chords that intersected inside the circle. Now what we're going to do is not 2 chords. Actually, let's push this over just a little bit. There we go. This should be a better spot. What we're going to do are 2 secants, all right? 2 secants. That would be 1 secant. And they intersect at a point not inside the circle, not on the circle, but where do you think? Outside the circle. Now again, it doesn't matter what angle or anything like that, just like that. Now that would be a secant. It would keep going. Technically a secant is a line and it keeps on going, but we're going to stop it at the point of intersection. In fact, we're going to come up here on this line, and we're going to stop this line. Instead of having to go all the way through, we're just going to talk about the segments that it makes, so we're going to stop it right on the circle. Is that okay? So yeah, it's still a secant. You can think of it as keep on going forever, but just to make it a little easier to look at, I'm going to just end it right on the circle. So there's our situation. There are 2 secants that intersect at a point outside the circle. We good? Now let's put some letters in here. What color you want? We haven't used that crazy color. Is that pink? Pink enough, I guess. A. It's kind of a pinkish purple, isn't it? C, D, E. All right, now watch carefully. What we're going to do is this. We are going to take this whole entire secant from the point that it intersects to this point on the circle right there. I call that the whole thing. All right? So what I'm going to do, I'm going to come up with a formula here. I'm going to take the whole thing, whatever the length that is. Okay, they're going to put numbers in here, obviously, aren't they? I'm going to put take the whole thing and multiply it by just the outside part. I'm just going to kind of color it in a little bit. just, oops, so you can see it. All right, that's kind of ugly.